Hello, everybody. Welcome to our notes about the layers of the Earth. Let's go ahead and get started. SWABOT. SWABOT is what I like to say, and it stands for students will be able to. So at the end of these notes, you should be able to describe the characteristics of the layers of the Earth, and you should be able to draw a picture or locate the different layers on an illustration. I need you to get out your Venn diagram in your notebook for the notes on the next couple slides. We are first going to talk about the two different types of crusts. The first one we're going to talk about is oceanic crust. So this is the crust that's underneath the ocean, the land that's underneath the ocean. It is thinner than continental crust. It's about 4 miles thick. It is younger or newer than continental crust, which we're going to learn more about later. And it's more dense than continental crust, which means it weighs more for the amount of space it takes up or its volume. So it's more dense. It's mostly made up of a rock called basalt versus continental crust, which is the layer of rock which forms the continents. It is thicker than oceanic crust, which makes sense, right? Because it's got to rise out of the oceans, about 22 miles thick, depending on where it is. If there's mountains, it can be even higher than that. It is older than oceanic crust, and it is less dense, meaning it weighs less for the amount of space it takes up. And it's mostly made out of granite, which is a kind of rock. Some of you might have granite countertops, which is a kind of rock that's been honed for counters. But there's lots of granite rock. You can find rocks all over the place that's made up of granite. So both of these things make up the crust of the Earth. You can pause the video right now and write in the middle of your Venn diagram, what do these two crusts, the continental crust and the oceanic crust, have in common? You can fill out, there's a few things maybe you can think of there. And we're going to move on to, when you're finished with that, to the crust. So the crust is the outer layer of the Earth. It is made up of both land and the crust under the ocean, which we just talked about. It's the thinnest layer of the Earth. It's like the skin of an apple. So if you cut an apple in half, that skin is very, very thin part of the apple. It's about 3 to 31 miles thick. So that obviously that depends on where it is. It is also the coolest layer in temperature of the Earth. And the lower you go inside the Earth, the hotter it gets. The lithosphere is a vocabulary term that includes the crust and the very top part, the solid part of the mantle. So the lithosphere is what we call the very outer part of the Earth. It's got two different parts of the crust and the part of the mantle. So the next layer is called the asthenosphere. It is the next part of the mantle. The crust moves over the asthenosphere, and it is not quite as solid as the lithosphere. It moves like a silly putty or any of those kind of putties that you guys have played with. So it's kind of thicker than slime, but it can move. So it's a solid that can move and take on different shapes. So that's what the asthenosphere is made up of. And that's going to become really important later when we talk about other things like the tectonic plates. The next part of the Earth's layers is called the mantle. So the mantle includes the part of the lithosphere and the asthenosphere, but it's much bigger than that. It is the largest layer. It makes up 84% of Earth's volume. It's about 1,800 miles thick. The main part of the mantle that we will talk about a lot is that there is a process in the mantle called convection, which makes heat rise. The rocks can move inside the mantle. Hotter rocks rise up. They cool off towards the crust, and then they sink back down. So if you think about your house, the warmest rooms of your house are on the top floors, and the coldest rooms of your house are on the bottom floors. So those hot rocks rise, and then they sink back down, and that's going to become really important when we talk about more things in the future. So the mantle can be about 1,800 degrees near the crust, and versus almost 6,700 degrees Fahrenheit near the outer core. So there's a big variety of temperatures in the mantle. The next layer is called the outer core. It is the second biggest layer. It is about 1,400 miles thick. It makes about 15% of the Earth's interior. It is the only liquid layer of the Earth. We're going to talk more about the putty-like asthenosphere, but that is considered a solid, even though it can move a little bit. The only true liquid layer is the outer core, and it is made up of liquid iron and nickel, which are very heavy elements, heavy metals. So that liquid moving around in the outer core is what helps create the magnetic field of the Earth, and the temperature can range there from about 8,000 to 9,000 degrees Fahrenheit. The final layer of the Earth is the inner core, the very center of the Earth. It's about 775 miles. It only makes up about 1% of the Earth's volume. It is a solid layer, and it is made up of solid iron and nickel. It's a little over 9,000 degrees Fahrenheit, and it's so hot that it melts the liquid part of the outer core. It is also the densest layer of the Earth. It is the most weight that taking up its volume. So the next question I'm sure you're maybe wondering is, how in the world do we know what these layers are like? We haven't been to the outer core. We haven't even really been into the mantle. We have not dug, if we are digging holes in the crust of the Earth, we have not dug very far, and so we haven't been to these other layers. So how do scientists know what they're like? And they know what they're like because of something called seismic waves. Seismic waves are waves of energy that are caused by earthquakes and other movement of rock. And different waves travel through different things. And so scientists can look when there's an earthquake and they can measure these waves in different places. And that's how they can determine what things are made up of. So here is a little picture of, if on the top of this we have the epicenter of an earthquake, the center of an earthquake, and we can measure different types of seismic waves, and some seismic waves cannot move through liquid and some can. And so if we have an earthquake, scientists can measure these waves on different parts of the Earth, and that is how they know that the outer core is liquid, because certain waves can't go through it, and the way that they deflect from there makes them know that that's what the outer core is made up of, is a liquid. So they can examine these seismic waves and determine what the different layers of the Earth is like. So that's how scientists know that. Some discussion questions. So some things that I would like you to be able to know after these notes, after you've taken all of your notes, is which layer is the thickest? Which layer is the hottest? Which layer is the only liquid layer? Which layer is the densest? Can you think of a relationship between temperature and the different layers of the Earth? We're going to discuss more about this in class. And in closing, I've got a little meme there for you about layers. And just remember that science rocks.